We want to look at some theorems that involve polynomials, and the first one we call is the remainder theorem. So, and we've seen this factorization before. This division, sorry, before, where we get x cubed plus 2x squared minus 3x plus 4 is equal to x minus 3 times. So when it was divided by x minus 3, we got the quotient there plus 40 remainder. So if we just look at the polynomial there and look at the result of P3, so substitute 3 in there, we should get 40, and recognize that hopefully that's the remainder. So we've substituted 3 in there and got the remainder and got the value being 40. So why is that the case? Well, if we have a look, if we substitute 3 in here and we substitute 3 in here, that would actually give us 3 minus 3, which is 0. So those two parts would actually be a 0 times something. We don't really care. But that part would be 0, leaving us just the 40. So that substituting 3 in there should equal the 40, which is the remainder. Now that's what we call the remainder. This is what we call the remainder, or where the remainder theorem comes from. So we're going to divide some polynomial by a linear term. It only works with a linear term, so just keep that in mind. If quadratic, it doesn't work. So what we need to do is, if we divide a polynomial by a linear term, we get this situation. X minus a is the divisor, and we divide in the polynomial. We get it multiplied by some quotient. You're going to get this. The divisor times the quotient, always, plus a remainder. Now, that remainder is going to be a constant, because x, it's got to be less than, a lesser degree than the x minus a, which is a degree 1, so that's got to be a degree 0. So that's why it only works with a linear term, because we're going to get we're going to get a number as a divisor there, as a remainder. So if we substitute x is equal to a, if we've got this dividing by the term there, we divide by a, the a minus a would equal 0 times the qx, which means that p of a would equal to the remainder, and that's how we get p of a being equal to the remainder. So that's where the actual theorem and the proof of the theorem of why when we substitute we'll divide by x minus a, and we substitute a in there, we would get the remainder. So that's what the remainder theorem works there. So there's the actual theorem there. So it's dividing by, when you divide by x minus a, we're substituting p of a. So it's whatever that term there. If it was x plus a we're dividing by, a would be a negative term, so it's similar to what we've got there. So if we're using the remainder theorem here, so dividing x minus 4 by into this, what would be the remainder? We'll substitute p4 in there, we're going to get 41. So we don't even need to do the division, because it's going to be in that form. It's going to be x minus 4 times something plus a remainder, and that remainder, when we divide by x minus 4, will be 41. So it's an easier way to get the remainder without actually doing the division. This is what the theorem works for us. So x squared plus 5x plus 3 divided by x plus 2. Substitute minus 2 into the polynomial, and we get minus 3 as our remainder. See, 2x cubed minus 4x minus 1 divided by x plus 3. So we substitute minus 3. Because it's x plus 3, we put the minus 3 in, and we get a minus 43. So again, you can see how we're putting in whatever the value is. So x minus 5, we're going to substitute a positive 5 in to get a remainder of 9,424. So it works the same way each time. This one's a little bit different, because we get x minus 1, so we substitute 1 in, and what we're starting to notice is 0. Now that's going to bring in our next theorem that we call the factor theorem, because there's no remainder. So basically, in this case, we're going to get our polynomial would be equal to x minus 1 times the quotient, times some quotient. Basically, it means that x minus 1 times the quotient gives us the polynomial. X minus 1 must be a factor. So, and that's where that comes about. If we get a remainder of 0, we know that term must be a factor, and we're going to talk about that in the next video on factor theorem. So, using our remainder theorem and the ideas, we want to find k. If the remainder is 3, when we divide that by x minus 1, well, what would we get? Well, p1 would, when we substitute it in, because it's x minus 1, so we substitute 1 into the equation, the remainder ends up being 3. So P1 is equal to 3. That's what that means. So we do the substitution. We end up with an equation just in terms of K, which means that K would be equal to 8 when we do that solution. So it's just using the remainder theorem to solve a problem that's a little bit different. So again, remainder is 4 minus 4. So P of minus 2 is equal to minus 4 because we're dividing by x plus 2. So that's where we get the P of minus 2. Do the substitution, set it equal to 4, and there's we are able to solve for K. So it's just using the remainder theorem. Remainder of 0, dividing that by x plus 6. So again, do our substitution equal to 0. We're able to find the value of K. So there's our remainder theorem. It allows us to solve a few problems, but it also leads in, as we said, to the next part, which is on the factor theorem.